We're going to need to factor polynomials just like we factored quadratics to find the zeros, but it's not going to be as easy as factoring quadratics. So with factoring polynomials, we're going to be forced to do some long division. All right, so let's work on our long division and our shortcut for long division called synthetic division, and then I'll explain how we can factor polynomials that way. Okay, so what I need to do is build this skill of dividing. And we can also I'll talk about this too as I do these problems when we get a remainder, how to deal with that guy. Okay, so here's my first example. Let's figure this out by examples. So I have a polynomial and I want to divide it by another polynomial. Might need some more room here. These can be kind of long problems, so let's give ourselves some more room to write with. Okay, so I'm going to do long division first. Long division. So a real quick review of long division. If I want to divide like 4 into 1231, I would set up the long division, 4 into 12 3 times, and then I'd go 3 times 4, 12. And then I'd subtract. And then I'd bring down the 3. 4 into 3, 0 times. 0 times 4 is 0. Then I'd subtract, and then I'd bring down the 1. 4 into 31 7 times. 7 times 4 is 28. Remainder 3. Okay? Back to this little definition right here. If I divide something with a divisor, I get the quotient plus the remainder over the divisor. I can do this with polynomials division, but for my example here, what does that look like? That means 307 divided by 4 is the quotient, 1231 divided by 4, that's what we divided. 1231 divided by 4 is the quotient plus the remainder over the divisor. Or this is called a mixed number. We usually don't have the plus sign when we're just dealing with numbers. But think about that for a second. This, I want you to connect this to this up here. If I have something divided by something else, I can write it as the quotient plus the remainder over the divisor. We can see that fairly easily with just numbers, and I'm going to be able to do that with polynomials as well. Okay? All right. So let's do long division on this one. So I have this cubic, y cubed minus 6y squared minus 2y plus 4, all divided by y plus 1. Now, how do I do that? I do the long division like I got over here. So I got y cubed minus 6y squared minus 2y plus 4. Myself a little more room. Y cubed. And I'm going to divide by y plus 1. Okay, so let's see if we can make the connection. I'm always going to focus on just the first term when I do long division, just those guys as I go through this. So I ask myself, y goes into y cubed how many times? It's y squared times, because y squared times y is y cubed. So just like with the numbers, I take this and I multiply it by the y plus 1. So y squared times y plus 1 is y cubed plus y squared. And then I subtract. And this first term should always go away when I do this. Y cubed minus y cubed is 0. Be careful with this next one because it goes negative 6y squared minus y squared. So it's negative 7y squared. Right, you have to subtract negative 6y squared minus y squared, negative 7y squared. Bring down the 2y. And then you repeat. Again, you just focus on the first number here. How many times does y go into negative 7y squared? It's negative 7y times, because negative 7y times y is negative 7y squared. But then you multiply the negative 7y by both of these guys, and I get minus 7y, and then you subtract. Okay, so be careful. Negative 7y squared minus negative 7y squared is 0. Negative 2y minus negative 7y, that ends up being a plus. Negative 2y plus 7y is 5y. Bring down the 4. How many times does y go into 5y? 5 times. 5 times 7y, or I'm sorry, 5 times y plus 1. 5y plus 5, subtract, and then I get my remainder. Okay, so 5y minus 5y is 0. 4 minus 5 is negative 1. Okay, so a couple things going on in this problem. One, this is the process of long division. If we get, here's what's coming up. If we get a 0 remainder, that means that this linear factor went evenly into this. So we're going to do those shortly. We're going to find things that are factors, and it'll allow us to factor this. That's what's coming up. But right now in this example, I just want you to know how to do the long division. And then another way to write this expression that I started with, this cubic divided by this linear, is equal to the result, y squared, minus 7y. This is like the mixed number version of polynomials. Y squared minus 7y plus 5 plus the remainder over the divisor. Okay, this thing, this fraction, if you want, or this division problem, can be written like this. The answer of the division problem, the quotient, and then the remainder over the divisor, just like we did over here. All right. Let's see. I also want to show you this doing synthetic division. All right, so I got a shortcut for this. Let me show you what it is. I take the coefficients only of my original problem. That's 1, negative 6, negative 2. 1, negative 6, negative 2, 4. Okay, so this is the same process, we just we're focusing on the coefficients. Okay, the 1, negative 6, negative 2, 4. And then I put the, out here, I'm dividing by y plus 1, but I put the 0 that corresponds with my divisor. That is the linear factor I'm dividing by. What's the 0 that goes with that? If I set that to 0 and solve it, to be negative 1. So anytime, we'll use this a lot in this section. Anytime I have a factor, like y plus 1, then the 0 that goes with that is y equals negative 1. Okay, so like if I had a factor, different example, if I had a factor of x plus 5, right, my linear factor, what's the 0 that goes with that? We learned this in the quadratic section. The 0 that goes with that, or the x-intercept if you want, is x equals negative 5. Okay, if you were to set that to 0 and solve. So in this case, I have my linear factor that I'm dividing by, y plus 1, and I'm dividing into this cubic. So I'm just using the coefficients. So see if you like this way better. Here's how you do synthetic. It's called synthetic division. It's a shortcut of long division when you're dividing by a linear factor. Synthetic division. So I bring down my 1. Negative 1 times 1, negative 1. I add negative 7. I multiply 7. I add 5. I multiply, and then I add. And look what happens. I get I draw a little line here. This is the remainder. And I understand that if I'm dividing a cubic, this cube, that was squared. I don't have to write these, but I'm just reminding you that we start with a cubic. I divide it by a linear. All right, that was x plus 1. It's a shortcut for doing the long division. So I end up with a quadratic. So that's got to be squared, that's got to be x, and that's got to be the number term. And this has to be the remainder. X squared minus 7x plus 5 with the remainder negative 1. Oh, I switched my variables to x, but you see we get the same thing. Okay, synthetic division and long division review. So we're going to have to use that in order to factor. This is the method we're going to use to factor polynomials.